Well, good day, everyone. I think last time we discussed, stopped at ports. Yeah, ports. So today we'll be talking about ports. Definition: virtual endpoints for network communication identified by numbers 0 to 65,535. Set purpose: allow multiple services to run on a single IP. Analogy: like apartment numbers in a building. IP is equal to streets, ports equal to apartment number. The Internet Assigned Numbers Authority (IANA) assigns and maintains port numbers for various services and protocols. So what port numbers actually mean is that, we said each device has its own IP addresses that is easy to communicate over the internet. Now, just like the analogy said, imagine you have an address to your house, whereby you live in an apartment where there are other apartments there. Now, the IP address only knows the location of your house, but the message that the person is bringing is actually going to a particular apartment in your house. So the person needs to know the apartment he or she is going to, so that you can get the message delivered. So your apartment number is like the port number. So it's port assists IP to allow multiple services to run on a single IP address. So the IP address is the address of your house, while the port numbers are the apartments, different apartments in your house, because the port number actually helps services to know the paths they're actually going to. For instance, now on the particular device, you are sending message through WhatsApp, you are browsing the internet, you are playing games, you are doing so many things just with a single IP address. If this IP address does not have port numbers that are actually supporting it, the IP address will not be able to multitask. So that is what port number helps. So as you are sending a traffic through WhatsApp, the port number that you are using will be able to tell the service, the WhatsApp service, okay, this is the direction you are going to, this is the service you are going to. So that is what port number is all about. So we have the range, we have 0 to 1023. These are the well-known ports. So reserved for system service like HTTP, Hypertext Transfer Protocol. Then we have FTP, File Transfer Protocol, and SSH Secure Shell. So we have 1024 to 49,151. These are registered ports assigned to applications like MySQL, RDP, Remote Desktop Protocol, which uses ports 3389. Then we have 49,152 to 65,535. These are dynamic and private IP. So most times when your systems or PCs makes a request to a website, it usually makes use of a dynamic or a private IP, because when you are visiting a website, it is actually your IP address that is going to look for the IP address of that particular website, so that there will be something we call three-way handshake, whereby your IP address goes to look for the IP address of the website server. Then the website server replies your IP address with what we call, okay, you making the request is known as a SYN, SYN. So the IP address making a response is known as SYN and ACK. Then by the time you acknowledge, your IP address acknowledges, then there will be a connection. So assuming you want to browse an HTTP website which uses port 80, now you can make a request. Your PC, when you visit the website, your PC can make a request with any of its dynamic or private ports, but because it is going to an HTTP website, the request is making the destination of the request will now be a port 80. You can make requests with any ports, but the destination, because it's an HTTP website, is going to be a port 80. So that is what this is all about. Let's go to the next slide. So we have common ports and protocols. So we have 2021, that's FTP for file transfer. when you want to transfer files, but it is always in plain text. It is not encrypted. So we have the encrypted version, which is the SSH, secure shell. Then we have telnet, port 23. We have SMTP, simple mail transfer protocol. This is used by email. So we have DNS, domain name system. We have HTTP, which is the insecure version. We have the HTTPS, which is the secure version. Then we have RDP, remote desktop protocol. Then we have IMAP, and we have SMB. So these are the common ports. So now we have port states. The port states we have open, which is actively accepting connections. We have closed, not listening, but reachable. We have filtered, firewall blocking access. So what this means is that, for instance, now in your apartment, now you open your door down, anybody can come in at any time. That means that particular port, if your room has a particular number, let's say that's the port number, so your door is open down, anybody can come in, which means at that time the state of that port is open. Then it is closed, assuming your door is closed, which means the state of that port is closed. Then we have filtered. Filtered is a situation whereby the door is open, but still, if anybody wants to come in, there's somebody there, or there's a security feature there for in the case of port numbers with firewalls that still questions anybody that wants to come in. That is what they call filtered. So let me try and show you a few examples of these states. Let me just show you something. So I'll be making use of this OWASP app. So I'll be trying the IP address. So I have 192.168.116.137. Right. So let's use nmap to check. So I say nmap have 192.168.116.137. So now you see this particular web server now is telling me that these particular ports are open. So you see port 22, which is SSH, port 80, port 139, port 143, 445. So it's telling me that the states of these ports now are open, which means hacker can actually exploit these ports. So that's what they mean by the states of a port. All right. Okay. So now we have the OSI model. Now the OSI model is also known as Open Systems Interconnection. The model has 7 layers that standardize communication functions. Each layer performs a specific role in data transmission, helps in troubleshooting and protocol design. So what OSI model actually means is, you might be wondering, how do we transfer data on a network? For instance, now I'm on my PC. I send a message to someone and it gets to the person. Now the process, the communication, the standardized communication this uses is not what we call the open systems interconnection, which is the OSI model. So we have 7 layers of the OSI model. We have the physical layer, we have the data link, we have the network, we have the transport, we have the session, we have the presentation, and we have the application layer. So now the physical layer, this is where, by the word physical, hardware transmission, whereby you connect your PC to a switch, or you connect endpoint devices to switches using cables. That is the first layer, which is the physical layer. Then the data link, this uses MAC addressing, whereby it knows the MAC address of each endpoint devices or each PCs that are connected to the switch. Then we have the network layer. This is where routing and logical IP addressing comes in. So this is where, if it is an automatical, it is an auto IP it uses DHCP at this point to give out IP addresses to devices. Then we have the transport layer. This is for reliable data transfer. We have the TCP and the UDP. So the TCP is transfer control protocol, and we have the UDP, which is user datagram protocol. So TCP is a protocol that is actually very reliable because it ensures that the transfer of your message or your information gets to the right source. For instance, if you visit a website and it goes to look for the IP address of the server, then the IP address of the server or the website server replies you with what we call a SYN and ACK. Then your IP now replies acknowledgement. Then that is a three-way handshake. So you can now start transferring messages between you and the server. So anything you send to the server, the TCP protocol always makes sure that your message gets to the server and it is received. While the UDP doesn't bother about whether your message is received or not. It just keeps sending your information. So UDP is used in situations like video calls. This live session we are having now will be making use of UDP because it has to be a fast connection whereby it keeps sending the data across, but it won't mind if the data gets to the source or it does not get to the source. Another example is probably online gaming. Online gaming is to use this UDP because it needs fast transmission of data. Then the fifth layer, we have the session layer, manages connections and sessions. So the session layer, for instance, if you visit a website, the website stays, let's say you visit a particular portal, your portal stays active for a long while, even after you've stopped interacting with the portal. What is making it still stay for that while is what we call the session cookies, whereby the session is still opens the session for you to be able to communicate with that particular server. So that is session layer. Then we have the presentation layer. It's data format translation. This is where encryption and compression comes in. So the presentation layer, this is where it decides whether your data you want to encrypt your data or you want to compress your data. Then we have the application layer. This is the interface for user applications like HTTP, FTP, DNS. So the application layer is like what you can see on your browser. You want to visit a website, you want to visit an HTTP website or HTTPS website, it's using the application layer. So now there's something we call encapsulation. Encapsulation is the process of you going from the application layer all the way to the physical layer. Then we have the encapsulation. This is the process of reversing itself from the physical back to the application. So what this means is through your PC, you send a message to someone. First, it goes to the application. Through the application, you can see it goes presentation, session, transport, network, all the way to the physical where it goes through the cables. If it's a cable connection, it goes through the cables. Then when it gets to the other person's PC, the encapsulation occurs whereby it reverses the process from physical back to you seeing what the person sent to you through the application layer. So these are the layers these layers are very important in network security because these different layers are what they use for troubleshooting. So at each layer, there are different vulnerabilities, different attacks that can happen at each layer. So network people, network guys usually try to know each layer so that when they want to troubleshoot, they know which layer the fault is at. So there's a code actually used in remembering this. We have the PDNTSPA. So what I use is, please do not throw spoiled pizza away. So you can come up with any code for yourself, just for you to remember the breakdown of the layers. So introduction to network security. Network security involves strategies to protect data integrity, confidentiality, and availability. So as we know, as cybersecurity personnel, the whole essence of our existence is to protect the integrity, confidentiality, and availability of data. So it defends against threats such as unauthorized access, data theft, and attacks. Requires a combination of hardware, software, and policies, just like we did in our last class, where I showed you how to segment networks. So it's also part of network security, whereby you make use of switches, routers, firewalls, just for you to secure the network. So we have common threats, common network threats. We have malware. Malware is malicious software. This is software designed to damage or gain unauthorized access. That is, when a malware, examples of malware, we have the Trojan horse, a malware that comes in disguise of a good application or a good software. Meanwhile, it has its bad intentions towards you. That is what they call the Trojan horse. Then we have ransomware, whereby an hacker or an attacker or a threat actor encrypts your files on your device just for you to pay ransom. Then we have worms, we have virus. So those are different malwares some of the malwares that we have. So these are parts of the common network threats that network security people face. We have phishing. Phishing, tricking users to reveal sensitive information. Now, what phishing is all about is we have different types of phishing. So let me just explain what phishing actually means. Phishing is a situation whereby a threat actor or an attacker sends you a message or calls you just to try and trick you or convince you to reveal sensitive information. So it could be through email. Through email is called phishing mail. Then we have vishing. This is through voice call. We have smishing through text messages. Then we also have whaling. Whaling is a situation whereby the attacker targets like a superior in the organization. That is what we call whaling. Then we have spear phishing. Spear phishing is a situation whereby the attacker has done reconnaissance on you to know the kind of things that you like. Probably the person visits your Facebook page, visits your Instagram page, or any of your social media pages to know the kind of things you like, so that threat actor can design a phishing link that will suit what you like, so that it will be easy for you to be tricked. So that's what we call spear phishing. So most times phishing attacks, we have ways to recognize phishing emails. So for instance, phishing email always wants you to make the response. It gives you a prompt, you want to make a fast response. You see messages like, we realized that you have issues with your bank. Click on this link now. So it prompts you to do it immediately, or there might be the errors in grammar of the way the messages are being typed. You might see a situation whereby the logo they are using is not actually the logo of the actual site. Then when you over the links also, you might notice that the link is an HTTP link, which means it's not secure, or you could copy the link and paste on a site called virustotal.com. So when you paste it, the website will show you if the link is actually a bad one or not. Another common attack on network is DOS. I think I explained DOS the other time. So DOS attack is like I told you, when you want to visit a website, your IP address sends a SYN request called SYN request to the IP address of the server, requesting a connection with the server. Now the server has to reply with a SYN and ACK. That's the ACK is acknowledgement to your IP address. Then your IP address replies with an acknowledgement before the three-way handshake occurs. Then message it we start transmitting. So one thing about website server is that there is actually a limit. Depending on how expensive your server is, there are limits to which the number of requests or SYN requests that a server can take at a time. Maybe there are some times maybe you visited a website and you realize that it's slow, or it's giving you a 404 error, or maybe a school website, everybody's on the website, you realize that if you try to log into the website, it's slow. So now imagine that is because there are so many people that are sending SYN requests to request from the server at a time. That is why that is occurring. So now a DOS attack. Now a single person now uses a tool to send multiple SYN requests with his own particular IP address, to send millions of requests to that particular website so that the website will crash. So that is a DOS attack. Then DDoS attack. This is distributed denial of service. Now, this is a situation whereby the hacker now employs different PCs, we call them bots. So through this phishing link, through phishing link, an hacker can actually employ different PCs, whereby if you click a link that you're not supposed to click, you don't know that your PC has been employed as a bot. So now the hacker will now use all these PCs to send requests to that particular website. So that is a DDoS attack. So imagine you with your own PC, you are sending millions for a DDoS attack, you are sending millions of requests to a website. Now you now employed multiple PCs as bots to send, as you are sending millions, they're also sending millions of requests to that website. So one of the mitigations of this kind of attack is where you see Cloudflare. Some websites make use of Cloudflare, some make use of I'm Not a Robot. Now all these things are mitigations against DOS attacks. Now another common network threat, we have packet sniffing, capturing data packets in transit. Now packet sniffing is a situation whereby an hacker uses different tools, could make use of Wireshark, could make use of Bob suits to capture, to sniff the packets that is being transferred between a network, whereby the hacker is monitoring the packets that are being transferred through the network. So if you transfer a file and the file is in plain text, an hacker can actually capture that file and read what is inside the file or access the file. That's what they call packet sniffing, whereby a cyber criminal can actually capture the way your message, because I don't know if you were in the last class, I explained packets to you. Now, if you send a message on WhatsApp, if you send a message on WhatsApp from your friend to another person, now the message goes in what we call packets. Now, these packets, there are tools that actually shows you how these messages are actually moving. So that's why WhatsApp will tell you it is end-to-end encrypted, which means any packet on transit is encrypted until it gets to the receiver. So there are some packets like that that are not encrypted. For instance, if you are transferring using the FTP, which is not encrypted, you could have a sniffer that sniffs your packets and captures the file you're actually sending. Then we have man-in-the-middle attack. This is intercepting communication between parties. Now, man-in-the-middle attack occurs whereby a cyber criminal is between your message and the receiver. That is why most times they advise you not to join a public hotspot when you see your spot, because you feel it's free, you just join, because it's easier for a man-in-the-middle attack to occur when you're on the same network with the person. So the person can actually change your messages from going to the receiver, or could actually change what you are sending to the receiver. Let me see if I can. Oh, we still have time. Let me show you an example of a man-in-the-middle attack. So head over here. Let me use the vulnerable site. So let me put on. So my Bob suit is on. Then my browser. Okay, now, so this is a vulnerable website now. Let us try to log in. They said the password is test, username test. Okay. Exactly. Okay. So now let me show you something. So let us change this. Let's say I put 20. Let me put 20 here. Card number 1, 2, 3, 4, 5. And let's say any at gmail.com. Number, let's say 2, 3, 3, 4. This, let's use this. Address my house. So now let me do something now. What Anaka can do when you're on the same network with Anaka to perform a man in the middle attack. So let me intercept this request now. So now let me update. Now you notice that it's still loading as if there's network issue, but meanwhile it has been intercepted by my Bob suit. So a threat actor, if you're on the same network, you can actually perform something like this to intercept your request. So now on my Bob suit now, you will see this is the what I intercepted. So on an HTTP website like this that shows everything in plain text. Imagine you visit a website like this and an hacker intercepts your request. Let's assume the details you even put are details that are very sensitive. Probably you have those details used in almost all your sites, especially those that use the same details in all their sites. Now imagine it was a change password session that the attacker actually intercepted. So this could actually make you vulnerable. So let me just show you something that we could do right now. You know, the name I inputted was Tony, right? So let me change it to and okay, let me just put 5 here, then email, let's say test or at and address, let's say you have been hacked. So now I can forward this and turn off the intercepts. Now see what happens. Now can you see that the details that's updated are the details I put after intercepting. So imagine a threat actor intercepts your request like that. He or she can do and undo with your details, can copy your details, can change the details that you want to send. Imagine it is a change password, a site that is not encrypted, and you want to change your password or you want to input your password, and the attacker intercepts it. This could also happen whereby the attacker will copy your password, especially if you're someone that uses the same password for all your sites, which is not advisable. Could copy your password, could do so many things. So this is an example of a man in the middle attack. Then we have network security tools. We have firewall. Now firewall monitors and controls incoming and outgoing traffic. So you can use firewall to filter traffic. Maybe you don't want a particular IP address to come into your system, or you don't want your system to be able to visit Google, or you don't want your system to be able to visit a particular site. You can actually use firewall to filter that. Probably one of our classes will do a practical on how to use firewall to filter. Then IDS and IPS. IDS means intrusion detection system, and IPS means intrusion prevention system. Now, the IDS, we actually have two types of IDS and two types of IPS. We have the network-based and we have the host-based. Same thing for IPS too. We have the network-based and we have the host-based. Now, for the host-based, you have to configure it on each of the PCs in that particular organization if you want to make use of IDS host based. But if you want to make use of network based, once you configure it on the network, then it affects every other person on that network. Same thing goes for the IPS, intrusion prevention system. We have the host based and we have the network based. For the host based, you have to configure it on all the PCs personally. Then network based, once you configure it on the network, it affects everybody on that network. Then we have VPN. This is virtual private network. Now, what VPN does is that VPN helps you to route your packets through a secure tunnel. So, for instance, now you want to visit a site now. If you are making use of VPN, instead of the server of that site to see your own IP address, it sees the IP address of the VPN hosts you are using. So it will route your traffic through that particular VPN tunnel. So instead of it seeing your own IP address to show that you are the one that visited the website, it sees the IP address of your host VPN organization. That is what VPN. Then we make use of antivirus and anti-malware. We know what antivirus is. Most of our Windows come with antivirus. So antivirus is also a security tool in network security. Then we have SIEM. This is security. This is a security management tool. We have security. The full meaning is security information and events management. So what this tool does is that it keeps logs of real-time threat detection. That is, everything, for instance, everything you do on your PC now, Windows has its own logs, whereby when you logged into your PC, when you logged out of your PC, some functions, some actions that you made on your PC, it has a place where you can check the logs. It actually keeps logs of those things, that is everything you've done on your PC. So the same thing for the SIEM tool. So one of the two we have Splunk. Now, Splunk is one of the tools we use in network security. It keeps logs of everything that has been done throughout that particular day in real time. So you can always investigate to check. It will save the time maybe when the user logged in, when the user logged out. So you can always check to see if a user logged in at the right time or if a user logged in at the wrong time. You can use this to investigate. So we have network security best practices. We have implement strong password policies. Always implement strong password policies. A strong password includes 8 characters with at least 8 characters with capital letters, small letters, and symbols or characters. Because if you use, for instance, now maybe you use just practice or you use a name as your password, it takes an hacker a few seconds to hack that particular password. But if you make use of capital letter, small letter, and characters, it could take an hacker years to hack that particular password. So that's why it said you should implement strong password policies. Then enable two-factor authentication, a 2FA. So two-factor authentication is whereby you want to log into your site or you want to log into your platform. When you click in your password, it will direct you to maybe use a Google Authenticator, or you use your email to receive OTP. So that is two-factor authentication. I'm sure most of us don't have two-factor authentication on our WhatsApp. So try and put two-factor authentication on your WhatsApp so that when your WhatsApp is cloned or when they want to clone your WhatsApp, you'll be able to mitigate that. Then we have segment networks to limit exposure. So I've explained segmentation the other time. We tried using packet tracer to segment networks so that if a network is compromised by an hacker, the other network can be disconnected so that it will not also be affected. Then we have update systems and patch vulnerabilities regularly. So always update your systems and patch vulnerabilities, because any vulnerability, any patch that is left unpatched could actually be exploited by an hacker. Because the reason why they update most of these systems is maybe because they found a vulnerability in the former patch, so they want you guys to patch it up so that it will not be exploited by an hacker. So we have educate users on cybersecurity awareness. Yeah, you have to always educate users because record has shown that the most people that are vulnerable to attacks in organizations are end users or endpoint users, because they are not, if you are not really aware about what is going on in their surroundings or aware about security best practices, they could do and undo. And one of the greatest threats you can have in an organization is an insider threat, because the person is already in the organization. So any form of threat the person brings to the organization can easily affect the organization more than the one coming from outside the organization. So always educate users. When you see a phishing link, try not to how to recognize phishing links and some best practices, passwords, multi-factor authentication. Yeah, so that's all we have for today.